Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to be learning how to solve quadratic equations by using what's called the quadratic formula. So let's get right to it. You can solve any quadratic equation in standard form, which is ax squared plus bx plus c equals 0, by using the quadratic formula. And by any quadratic equation, I mean whether the numbers are large or small, decimals or fractions. And the quadratic formula states that x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So let's use it. Use the quadratic formula to solve each quadratic equation. So first things first, we always want to make sure that the given equation or function is in standard form. And for this first example, A, it is in standard form. Please remember always that whenever you don't have a number in front of a variable, there is an invisible coefficient of 1 there. So my A is 1, my B is 4, and my C is negative 3. So x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a, which is 1. Please feel free to go ahead and use your calculator to calculate the inside part of the radical, which is called the radicand here, what I'm highlighting in blue. Just be sure to go ahead and make sure that you write the parentheses exactly as they're written here on this example, or on any example that you create. So x is going to equal negative 4 plus or minus 16 plus 12 is 28 divided by 2. Please remember that you can have to simplify the radicals. For the most part, they're always going to require you to express the answers of a quadratic formula in radical form unless otherwise stated to do so in decimal form. So 28 can be split up into a 7 times 4, and remember that the square root of 4 is 2. So x here is going to equal negative 4 over 2 plus or minus the square root of 4 is 2 with the square root of 7 left over 2. Why did I split up that 2? Because the 2 here in the denominator is the distributive property of division. So it's getting divided to the negative 4 and to the value of square root of 28. And this way, by doing so, you can go ahead and simplify in one fell swoop. So x is going to equal negative 2 plus or minus the square root of 7. And those are your answers. Next, for example B, we're going to go ahead and first start with subtracting 4 to both sides to get it into, once again, standard form. So I've got 2x squared minus x minus 4 equals 0. My a is 2, my b is negative 1, and my c is negative 4. So x is going to equal negative b, remember that's a double negative there, plus or minus the square root of b squared minus 4 times a times c divided by 2a. So x is going to equal 1 plus or minus the square root of 1 plus 32 is 33 over 4. And there you have it. X equals 1 plus or minus the square root of 33 over 4. If you cannot simplify the radical, then you can't simplify it, and that's your answer. Next, for example C, we've got it in standard form. Remember that there's an invisible 1 in front of the x squared. So A is 1, B is 6, and C is 9. So x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So x is going to equal negative 6 plus or minus 36 minus 36 is the square root of 0 over 2. Remember that the square root of 0 is 0, so we've got negative 6 over 2. So therefore, x equals negative 3. When you just have one answer, that is called a repeated root. Okay. Now, the discriminant of a quadratic equation or function in standard form, ax squared plus bx plus c equals 0, is the value of the expression b squared minus 4ac. What is so special about the discriminant? Well, you can use the discriminant from the quadratic formula in order to find out how many solutions you will have before even solving the equation. So it's pretty handy to know how many solutions you're going to have and what kind of solutions they're going to be. Once again, the discriminant is the inside part of the radical, or in other words, the radicand. You do not have to find the square root of it. You just need to find the value of b squared minus 4ac. So let's look at some examples here. If b squared minus 4ac equals 0, then that means we have one real root, which means that it touches the x-axis once. So if you can see here in my example, the parabolas are simply intersecting the x-axis at one point, whether they're pointing upwards or downwards. If b squared minus 4ac is greater than 0, or in other words, if it's positive, you have two real roots, which means that it touches the x-axis twice, as you can see here in the graphs, whether they're pointing upwards or downwards. Now, a cool little note. These are two real rational roots if you have a perfect square value for the b squared minus 4ac. And they're two real irrational roots if it's a non-perfect square value for the b squared minus 4ac. And then last but not least, if b squared minus 4ac is less than 0, in other words, if it's a negative, then you have no real root. In fact, you have what's called imaginary roots. That means that it's never going to touch the x-axis. As you can see in both parabolas here in this example, they never intersect or touch the x-axis. Now, imaginary roots can also be written as what's called complex roots. They're called imaginary or complex roots because you have a negative inside of the radical. And remember that the square root of negative 1 equals I, which is an imaginary number. All right, let's look at some examples. Find the number of real solutions of each equation below. Well, I should have just said find the number of solutions because they can be real or imaginary. So let's get right to it. Our first example is in standard form, and my A is 2, my B is negative 3, and my C is 7. So b squared minus 4 times a times c is going to equal 9 minus 56. So 9 minus 56 is going to be negative 47. So that means I have no real roots. Rather, I have imaginary or complex roots. That means that I'm never going to intersect the x-axis. It never touches the x-axis. Next, let's go ahead and rewrite this as standard form. So I'm going to subtract 6x and negative 5 to both sides, giving me now in standard form x squared minus 6x minus 5 equals 0. My A is 1, my B is negative 6, and my C is negative 5. So I've got B squared minus 4 times A times C. That's 36 plus 20, so that equals 56. So I have two real irrational roots. So that means that the parabola will intersect the x-axis twice, but it's irrational because once again, 56 is not a perfect square. If it was a perfect square, then it would have been two real rational roots. Okay, let's look at a real life example. The revenue received by a company selling X specialty t-shirts per week is given by the function R of X equals negative 0.005 X squared plus 30X. How many t-shirts must be sold in order for revenue to be 25,000 per week? So they're giving you the revenue R of 25,000. So let's start this by going ahead and evaluating the value they gave you. So they want the revenue to be 25,000, and we want to find how many X t-shirts we need to make a revenue of 25,000. So first things first, after we plug in our known values, we're going to go ahead and rewrite this in standard form. So I'm going to subtract 25,000 to both sides. That's going to give me 0 equals negative 0.005 x squared plus 30x minus 25,000. So my A is negative 0.005, my B is 30, and my C is negative 25,000. Okay, so now let me go ahead and shrink this a little bit to give us some space. Let's go ahead and use the quadratic formula. That's exactly why we have a quadratic formula for difficult situations like this. This would be quite difficult to factor or complete the square. So my X, the number of t-shirts, is going to equal negative B plus or minus the square root of B squared minus 4 times A times C over 2A. So when we use our trusty calculator, we're going to see that X equals negative 30 plus or minus. When you go ahead and calculate the radicand, I promise, go ahead and use your calculator, you're going to get 400 over negative 0.01. Okay? So now the square root of 400 is 20. So this is going to equal negative 30 plus or minus 20 over negative 0.01. So we've got negative 30 plus 20 over negative 0.01. And when we use those calculations, we're going to go ahead and see that it's negative 10 divided by negative 0.01, which equals 1,000 t-shirts. Or when we have negative 30 minus 20 over negative 0.01, we're going to find out that we can get $25,000 of revenue if we also sell 5,000 t-shirts. And there you have it. You're going to make a revenue of 25,000 if you sell 1,000 or 5,000. Now you may ask, how is that possible? Remember that we're dealing with a quadratic equation. Remember that we're dealing with a parabola. So in a nutshell, I'm not going to go ahead and graph it exactly, but I'm going to give you a sketch. What's happening here is, remember that the A is negative, so it's pointing downwards. So I've got a parabola like this here, and we're looking for when we're going to earn 25,000. Well, here at 1,000, we'll make the 25,000, and here at the 5,000, we'll also make the 25,000. Now you may say, how is that possible? Well, it's called the law of diminishing returns. Remember that in anything that you're selling or buying or manufacturing, there are costs involved. And sometimes, believe it or not, the more you sell, the more costs you have, therefore reducing the amount of profit that you're going to make. So in our particular case here, our goal is to sell 1,000, because at 1,000, I'm going to make $25,000. It's much more wise than trying to sell 5,000 to make the same $25,000. And that's why you can have that differential. All right, next example. A window designer wishes to design a window so that the diagonal is 20 feet. In addition, the length of the window needs to be 4 feet more than the height. What are the dimensions of the window? Well, we've got a window here, okay? Got a window here, rectangular window, and the diagonal is 20 feet. And we want the length of the window to be 4 feet more than the height of the window. So we don't know the height. We'll go ahead and call that h. But we want the length of the window to be 4 feet more than the height. So we want that to be h plus 4. So here we can go ahead and use what's called the Pythagorean theorem, which we have investigated several times before. So a squared plus b squared equals c squared. So I've got my h squared plus h plus 4 squared, remember, is a perfect square. So it's the square root of the first term plus 2 times the first times the second. So 2 times 4 times h is actually 8h plus the second term squared equals 20 squared, which is 400. We're going to go ahead and simplify this and write this in standard form. So I've got 2h squared plus 8h. Then I subtract the 400. So 16 minus 400 is going to give me negative 384 equals 0. Always scan for a common factor. And in this particular case, the greatest common factor is 2. So I'm going to go ahead and divide 2 to everything. No, we don't need to do it. That's the whole point of having the power of the quadratic formula. We can use any numbers, but why not? It's going to make our life even simpler if we can go ahead and factor out a GCF. So now my a is 1. Remember, that's the invisible number in front of the h squared. My b is 4, and my c is negative 192. So h, which is what I'm looking for, the actual height, equals negative b plus or minus b squared minus 4 times a times c over 2a. So h is going to equal negative 4 plus or minus the square root of, I can calculate my 4 squared minus 4 times 1 times negative 192. Make sure that you're using parentheses properly, and that will give me 784 over 2. The square root of 784 equals 28. So my h is going to equal negative 4 plus or minus 28 over 2. So h is going to equal negative 4 minus 28, which is negative 32 over 2, and negative 4 plus 28, which is positive 24 over 2. So my h height would be negative 16, which is not possible because we're talking about a real life situation, and 12. And that would be my height. My height would be 12. And in this case, we're talking about 12 feet. And the length, remember that the length was 4 more than the height, so the length would be 16 feet. And that, my friends, is how you use the Pythagorean theorem and the quadratic formula to solve real-world problems. Thank you so much for watching. Hope you learned a lot and come back anytime. Take care now. Bye-bye.